Hi gang, so this is the second video for chapter 10, section 2, so I'm calling it 10.2b. Anyway, and now we're going to get into the details of the light reactions. I'm actually pretty excited about this. And so we have this first picture here, and I'm just going to start by just refreshing where we're at. So we are doing the light reactions in the thylakoid membranes here, up on the diagram of the chloroplast. And what we're looking at is two photosystems here. And in the last video we talked about photosystems and how they worked and their structure a little bit. And what we're pointing out here is that there's actually two types of photosystems. If I look in a thylakoid membrane, there would be thousands of these just everywhere, photosystem 1 and photosystem 2. And they work together. Their names do not go with the sequence in which they work. Their names have to do with when they were discovered. So photosystem 1 was discovered first, photosystem 2 was discovered second, and basically photosystem 2 actually is what works first, and then photosystem 1 after that, so it's a little confusing. But anyway, the difference between these two photosystems has to do with the chlorophyll A molecules that are in the reaction center. And so the chlorophyll A molecule here in the first one, in photosystem 2, is called P680. Okay, and the reason it's called that is because the wavelength of light that most effectively energizes its electrons are wavelength 680. Okay, and if I look over at photosystem 1, it's called P700 because it works best with light that has the wavelength of 700 nanometers. So anyway, that's where they get their names from. So if we take a look at how they work here, if we look at photosystem 2 to start, and this will be a little bit of a review from the other video, but when light energy hits this, it's going to start to energize some of the pigments, and those pigments will pass that energy on from pigment to pigment to pigment until that energy ends up at the chlorophyll A molecules that are in the reaction center. Those chlorophyll A molecules, when they receive this energy, they specifically have a couple electrons that get to the excited state. And when that happens, we have a primary acceptor, primary electron acceptor up here, that its job is to basically strip those high energy or those excited electrons from the chlorophyll A molecules. And that's where we ended last time, with these primary electron acceptors holding the electrons. Okay. Well, if we continue with what happens here, this would be happening over and over and over again. So that chlorophyll A molecule just lost an electron, one of the two there, lost an electron. Well, if this is going to happen again, then an electron has to replace it, and this is where the water comes in. If you remember in our big picture here of the light reactions, water gets split in half. The oxygen is released as waste, and the hydrogens get passed on along with their electrons for later use. The reason that is happening is because this chlorophyll A molecule needs electrons. It needs to replace the electron that it lost. And so we can do that by taking the water and splitting it. Okay, so there's an enzyme that's involved here that takes the water, splits it, and I guess we could say it oxidizes the water so that the electrons are removed and they join this chlorophyll molecule. Okay, so that's where the water gets split. And then the hydrogens would be released into solution, and then later on, when the electrons get picked up by NADP later on, then the hydrogens would be taken back out of solution, some hydrogens, not these specifically.